Hey everyone, just give me send a little message when you drop in so that I know that you're there. Hey Kevin, nice of you to join me. So, actually I wanted to do a little survey today to see what people think about this stream. But there's I didn't want to use type form, I wanted to use a different form. Clicker, paper form. Hey Kevin. I can just do a Google form, to be honest, right? Nah, I'm gonna do that for next time. Anyway, let's see who's there. Shoot me a message if you're there so that I know that I can get started. Right now it doesn't seem to be anybody's there. All right. Ah, damn it. I didn't save it yesterday. All right. A couple more people are joining, all from Twitter. Let me know if you're there. Let's go to the dashboard. Let's see who's here. Chat. No. Okay. Looks good. Well, while this while people are joining, I can already set up the Bumblebee thing again. Yeah, I think I got a very good comment today. Very, very good. I appreciate it very much. Very much. I appreciate it a lot. Ah, Kevin, it was you. Now I can connect these two. Yeah, the XLR thing, the backend. So actually, yeah, I went through this too fast yesterday because you can see actually that they do set the EXLA backend here when you install NX, and that is probably the mistake that I've made yesterday. So thank you, Kevin. Much appreciated. Let me just install all this. Bumblebee. Let me save this somewhere. Because yeah, that probably was the issue why it was so damn slow yesterday. And also, yeah, I guess we can improve the caching there a little bit, but we will get into that today. I actually found in the Phoenix files here, this one, they have a really good example of how they use the GPUs that they provide to connect them to a Livebook. But I think they made it easier now with the implementation in Livebook, like the connection. But I guess, I mean, if this is fast enough on my CPU, then we can just test this locally without having to connect to a GPU. Hey man, today's agenda is that we will finally set up the sentiment analysis. So I will get this to work no matter what. So what we do now first is to just, you know, try to set up Bumblebee, download the bird model and run it again locally to see how fast we can, you know, how fast it is with a CPU backend. And once that is done, we will just add it to our application so that, like, not in a Livebook, but in our application, we can add the model and run the model there. And yeah, and then maybe we can deploy it. Not sure whether I will deploy it today. I don't know. But yeah, so that's the plan for today. Just get this thing to work. Let's see. So again, we want to download bird. Oh, that was really fun. Yeah, this was cached, so that's amazing. And now we can see how fast the XLA backend is. Ah, look at that. Kevin, you're the man. This is working. This is working, man. I waited like over a minute for that yesterday. I don't know what, yeah, the problem here was that we didn't set the global backend to the EXLA backend. I don't know. Probably, you know, if you don't set it, then it will just not do anything. But yeah, this is fast enough. We can actually time this. Let's see how fast. Wait, what was it again? Was it TC? Timer TC. And we wanna have it in microseconds. It's microseconds, so we need to divide it by 1,000. Let's see how fast this is. Time and the result. Okay, that is 0.07 seconds. So that is 75 milliseconds. That is fine. Use some worker pattern, get a post, pass it to a worker and forget, similar to XCOM data sharing object. That was my idea as well. I want to load the model into a GenServer, and then from our pipeline, we just call the GenServer one by one with a post, and then it sends us back the result. Yeah, you can see over-evaluated. Oh, is that so? Ah, you're right. Jesus, man, so many things happen on Livebook that I wasn't aware about. 75 milliseconds. That is good enough. Ah, look at that. You know what? Let's just get started. Let's just add this to our application. I'm pumped. This is great. Everything's working. Where is that? There it is. So we need to add. Let me make this much bigger so that it can read. Should be good enough. All right, we're gonna add all of this all that stuff here into our application now. So NX, EXLA, Axon, Kino, and Bumblebee. And then we also have to set the global default backend. Do they give an example how to do this in? Yeah, you know, this is actually a little problem where I am thinking, maybe we will run into issues with this because now all the documentation is tailored towards Livebook. But the configuration here is different from what you would usually do in a Phoenix application, for example, right? So now, like, where do I set this thing, for example? I guess I will set it in the config. So that's where I'm gonna try to edit. And I hope it will work. But you know, that is one of these issues. Yeah, that's why here NX is not defined. So I'm gonna add it to my application. I guess. Module NX is not available. Yeah, we need to fetch it first. Okay. And now if I compile, let's see whether we get a error or not. All right. Bye-bye. Thanks for dropping in, though. Okay, only Bumblebee and XLA are needed. Let's see. I mean, Kino, like we use Kino. Where do we need? Yeah, so we need Bumblebee. We need Bumblebee, and then NX. Yeah, true. We don't need all the other. We just need NX and Bumblebee. This is so fast. Let's see how it performs on a slightly longer text. Still all right. So this is 300 milliseconds, 94 milliseconds, 99 milliseconds. Should be fast enough. I mean, you know, it's not gonna be like 60 requests a second fast, but still we can make 10 requests per second, you know, like run sentiment analysis on 10 posts per second or so. Yeah, to set the config. Alrighty, that is great. Let me do this here. Config, NX, default backend, EXLR backend. Cool. Okay, now let's start our. All right. Yeah, so we're fetching the posts here. Good. Yeah, next up, we need to bring the model into a GenServer. So I'm gonna do this here in just simplified. Well, not simplified, just here. And then, what should we call it? Just model. I'm just gonna call it model. And in the app model, this is a GenServer. So we can just start a GenServer. Start link. And I'm gonna name this like this. All right, and now we need the init callback. Well, in the init callback, we're not gonna do anything, but I'm gonna move the loading to the continue handler. I mean, that's gonna be an interest, also a problem here. Like, how can we kind of cache the model so that the loading the model will be fast? Oh yeah, I saw that. Yeah, I saw that. That's a good one. I can run it directly as my supervision tree. It's not in the examples here. Let's go to serving. Ah. I saw that somewhere that you can just, right. Yeah, this is part of the supervisor. Serving JIT. Batch size, batch timeout. Do I have it in my application somewhere? Because I do need to run the module somewhere, right? Serving module, yeah. Wait, I think I need to go slower through this. But here, so to do here, serving allows us to define an Elixir process to handle requests. This process provides several features such as batching, partitioning, and distribution. Okay, to do so, we need to start a service process with a serving inside a supervision tree. Okay. Yeah, we can do that, but I guess, how do we load the module here? Okay. Wait, actually I saw that I believe here in this example there was a block. Yeah. Yeah, this is also again live book. Building your index. Well, it is a live book thing. Yeah, that doesn't work. Here. This is how we can do it. So we can add a model option here. Is that true? Where are the, I guess, new? Serving. What are the options? The second argument is a serving argument given to new. Default options. No. Hang on. Slowly. Start link. Isn't it start link? Yeah, there we go. Okay. Start link is the function where we can define all the arguments. So we have a name, a serving struct with a serving configuration. Okay. Batch keys, all available keys, but we don't really need those. Batch size, the maximum batch size. A default value that can be set with batch size, which applies to both run and batched run. Setting this option only affects batch run and it defaults to 1 if none is set. Note, batches received by the serving are not automatically padded to the batch size, just can be done with pad, NX batch pad. Okay. Batch timeout petitions. When true, start several petitions under this serving. The number of petitions will be determined according to your compiler and for which host it is compiling. See the module docs. I think petitions might be interesting. Then we can run it on multiple cores, I guess. Okay, so we need to look into NX serving struct. Where is our struct? There. Module. Huh. But how do we load? Because what we need, what we do here is we create our serving based on a model and a tokenizer. So we kind of need to have that callback. Yeah, and eventually what we receive here is a module, NX serving default, and some other stuff. So we need to call this function somewhere to get the options. Yeah, and actually if we would use Axon serving, we would have a model. It does, yeah. Here, that's what I see here. So when we call Bumblebee text classification, and then we have the model and the tokenizer, it returns a serving. And then it has a function for client processing, pre-processing, post-processing, streaming, no batch size. Yeah, and the argument here. So we just need to call this thing. And actually, if I see this block here by Dockyard, what they do here is they have a model argument. And in the model, they can actually define how to load it. So they have like a function callback here. Yeah. Not sure how we would do that in the serving. Yeah, I mean, can't we just load the module outside of this? But that's the thing. I would like to start this GenServer asynchronously next to my pipeline. However, that also doesn't make sense. I mean, why would we start the pipeline if we don't have the model yet, right? We can't really analyze anything. So maybe we should wait for the model to start and then only restart our pipeline. That would make more sense. Yeah. I mean, then our server start will be slower. Let's see. Okay. So in the stateful process workflow, and then we can set send batches. Yeah, and what is, so we also have this JIT function here. Is that, what is JIT? It creates a new serving by JITting the given function with def n options, but we don't want that. Yeah. I think what we can do is just to call the serving when we start our application. So we load our model and all when we start our application, and then we just hand in the serving here and start it as part of our supervisor. So basically we copy paste this code into a helper function. Yeah, you're right, but I can just remove this GenServer here. So in our application, I'm just gonna create this little helper function. Loads creates, I'm just gonna call it new serving. Well, and in here, that's where we load our model, the tokenizer, and then we return the serving. Just gonna call it serving, right? And then as part of our children, that is where we add this thing here. Yeah. So I will move that before, just after the, no, before the endpoint. Yeah, so in here we call serving. And I'm gonna call this, well, that's the name of our serving. Yeah. Hang on a sec. Oh no, I'm good. Somebody rang the bell, but my girlfriend is heading. I'm just gonna call this bird serving because it's our bird model. So let's see what happens if we start our application, how long it takes until it returns our serving. Oh, that was super fast actually. Do you see that? It took no time at all. I mean, yeah, I guess that we already downloaded the model, we cached it, and we just loaded, because in Livebook it was also super fast. I guess the caching there is similar. Actually, that's something I saw in the in here, this blog post by Fly. When in the Fly TOML, when they define the application, they also define the cache. So here, Bumblebee cache dir. And that might be, yeah, that might be the same then for Livebook and our local application. So that the cool thing here is now that, you know, if we load it in Livebook, our model, and then we start our local application, it's super fast. Yeah. All right, that's cool. All right, so now we have our serving, we have a name, and that means we can actually start calling it in our batch here. So this is where we get all the messages in batches of 10. And ideally we would now call our model here as a batch run. So let's see what this does. So we need to go nx batch, and that's how we create a batch. Concatenate, key, merge, new. So this one is stacks the given entries to the batch. Each entry counts exactly as a single entry. Okay, you can either stack to an existing batch or skip the batch argument to create a new batch. Oh, we could also concatenate, but yeah, this is fine. But do we, like, do we need to add like tensors here? Entries. Okay, well, let's go back to serving. Let's just copy paste this here. So we create a batch based on our messages. And this is basically our, these are our posts. And we create a batch based on these posts. And then we do a batch run. And I call this bird serving. So let me just inspect what it returns. Okay, let's redo this. Oh, it returns a NX lazy container not implemented for just a post, yeah. Of type bit string. Data structures given to def and NX must implement either a lazy container or container. Ah, okay. Okay, so we don't need to create the batch here. I'm just gonna do posts. Look at that, Kevin. Kevin's the man. Oh, person, sorry. That is working. Look at all these beautiful prediction scores. Wow. Cool, we got it working. This is so awesome. That was super easy. Isn't that unbelievable how easy this is? I mean, you know, if you know how to plug these things together, but like literally we just, like, what was it here? This is how we start our serving. You know, loading the model, then tokenizer, and creating the serving is 3 lines of code, 4 lines of code, like 5 lines of code, and then you have a sentiment analysis model running. What? This is awesome. Yeah. Yeah. Also, I would like to time this just to make sure that, you know, to see how long this whole thing takes. Well, funny that you say that. The whisper. So 2 things. First of all, you know, yes, you're not an expert. However, it is just these simple things, you know, and that already makes you an expert. Like that already provides value. You just know how to plug these things together. And yes, it's not that you understand like the model underneath and exactly how NX works and all. And you know, those are the real experts, I would say. But it is already good enough to just know how to plug these things together. And you know, because most of the time, this is all you do, right? You just need to plug the things together and then deploy it to production. You need to know, that's actually going to be our next problem. How do we deploy this to Fly? However, I already have a feeling that it will be pretty easy, but you know, let's talk about this later. But that's the thing, like you don't need to know all the details here. Like to somebody who has no understanding of any of this, you would already be a magician. Like you could say, oh, so you want to, you know, create an AI startup and you want to do sentiment analysis on whatever tweets or something, you know, like maybe news, like if you want to analyze the current news. For example, there would be an idea, a friend of mine, he worked as a student for many, many years in a company that literally read every single news article that came out about their clients. So those would be like big car manufacturers, companies. And well, they want to, you know, tap into the current news cycle. They want to understand, you know, are they talking positively about the company? Are they talking negatively about the company? Which topics are they discussing that is relating to us? And well, he did that for, I don't know, all his student life, like for 8 years or 6 years, he worked there, you know, got like 15 euros an hour or something, just reading news article. And if you could automate that stuff now with you know, well, AI, Elixir, whatever, like out of a sudden, okay, well, he wouldn't have a job anymore. However, like, you know, all this tedious manual work, which is magically happen in the computer, it wouldn't be as accurate as before. But again, then also you put humans in front of a computer and make them read articles for, you know, 6-8 hours at a time. Like they won't be super accurate at the end of it either. But what I meant is like, if you know you were that owner of the company and you come to me and you say, well, can you just automate away all these 100 students that I'm employing? And I'm like, sure, 5 lines of code, you're done, right? I mean, it's harder than that. But I mean, how would you look like to this guy? You know, you would be a magician. Like you would be a wizard, just like, you know, magically setting that thing up, and all of a sudden you have like a super powerful model running. So that's what I'm saying. I think it's always we gotta keep in mind how others perceive engineers, and especially people who work with Elixir and who understand that kind of stuff, you know? Because like this took me like what, half an hour to set up. You know, if I deploy to production, it would be like a day's work and get it running, and then out of a sudden you have a running pipeline there, you know? So yes, to other engineers, this might be like, cool, you know, whatever. But to people who are not engineers, this is still really, really, really impressive. Don't forget that. So, you know, yes, you can call yourself an expert. Well, I understand that you don't want to call yourself an expert, but to others, you're an expert, you know? And if you talk to stakeholders, if you talk to non-engineers, you're an expert. And, you know, experts get paid a lot. So if you just go in there and say, you know, I tinkle, like I worked with this a little bit, well, they will also not pay you that money. But again, the result will be the same. You know, eventually they are happy and they have a working pipeline. And whether or not you get more or less money for that work depends on how you sell yourself. So I'm not sure why I talked about this, but I just want to say, if you talk with non-engineers, make yourself an expert. I know it feels wrong. Yeah, it feels wrong. I also struggled with this a long time, but it's like a salesman. You're a salesman. You have to sell yourself. And I'm a consultant now too, right? I mean, I have pretty steady work with a friend of mine, but I would need to sell myself. I need to go to stakeholders, to potential customers, and sell them the world, you know. And of course, like I'm realistic about it. I say, well, this will or not, this might work or not. You know, this might take this long or not. This is possible. This is not possible. Be realistic, but eventually don't diminish yourself. Like just be honest, you know, and oversell yourself rather than undersell yourself, and then try your hardest to get to that level that you sold yourself at. And most of the time, like where you sell yourself and what you actually need to deliver is very different, right? Because with Elixir, you have so much power at your hand. Within a day, you can set up a, like, you know, here, a data processing pipeline with ML if you know what you're doing, right? I mean, this is our 4th day already that we work on this. But if I had known how to set this up, I could have done this in 2 hours. And then, you know, like 1 hour, I had that experience so often with clients where they were like, yeah, okay, so, you know, can we set up an API to fetch this data? You know, how long will it take? And then I'm always conservative. I will say a couple of days, maybe a week. And they're like, oh, okay, I expected months, but let's do it in a week. And then within 2 days, I'm done. Like, you know, then I maybe add a 3rd day for proper testing, documentation, you know, not only code documentation, but also like, you know, like documentation of the product in Notion or so. But man, like people were blown away by how fast you can do certain things with Elixir. And that's what I'm saying. Don't underestimate yourself. Anyway, long rant. What did I actually wanted to do? I wanted to log out the time here, right? So. Sorry, there was a little abrupt ending to my rant, but you got my point, I guess. Look at that. Well, for 10 posts at a time, we are always below 1 second. That is amazing. So we are between, and that is running on a CPU. That is not running on a GPU. That's amazing. Let's bump up the batch size a little bit. I want to see what happens if we have batches of 20. Wait, I need to, in the application, that was the other batch size here. So, because yeah, if we just handle, look, this is still under a second. Okay, 1.4 seconds, 1.6 seconds. Yeah. Now the question is, what do we want? Do we want to have slower batches or faster batches? Yeah, ideally we would, you know, log that somewhere where we can actually see, well, if we have batches of 5, of 10, of 15, of 30, Like where's the sweet spot? Because I'm pretty sure like just running the model, just calling the model, it might take a little startup time, a warm up time. And yes, like somewhere if you minimize that warm up time, then you're more efficient. Like if you do the warm up time and then you handle 100 posts, well, then you actually like you only warm up once for 100 posts. But if you do it for every single post, then you're slower, of course. But for now, I'm not gonna worry about that too much. But if I would analyze this a bit more, I would certainly do that. So I think I'm gonna set it to 15 because 15 might be around 1 second, and I think that is good enough if we just handle 15 posts a second. Yeah, see, 0.97, 0.92. Yeah. Sounds good. Man, that was so easy. I'm still blown away. Like once we connected all these kind of things, it was just so easy. All right. Okay, well, yeah, so the next thing that we wanted to do is store the whole thing in TimescaleDB. So what do we get back here? We get back we get a list of maps and they have predictions and they have neutral, positive and negative scores. And I already mentioned it yesterday, but we probably want to be a bit more conservative, or how you say, strict about how we handle these results. Because if you, for example, look at this result here, you see that our positive and neutral predictions are pretty close, like 0.51, 0.45, so the model wasn't entirely sure, is this like positive or neutral? It's very much in the middle. And we have two options here, or many options, but two that I can think of right now. One of them is that we either average all these scores. So, we would actually add the 0.51 plus the 0.96 in the next result, plus the next result. So then we would, always take the scores, or we would just be a bit more strict and say, well, the highest value here is positive. So we're going to convert this to like a 1, and the rest is going to be a 0. And we're going to add up and average up all the 1s and 0s, basically. I heard in classification that is a better way to work with that stuff, because you will always have some uncertainty, and sometimes you get a better result when you're more strict about this, so yeah, I would say let's do it that way. Let's just find the highest value and then like add up these numbers. Yeah, so actually we're gonna do that in the result here. Average. Yeah. So we're gonna predictions. I can't write predictions. How do you write predictions? There you go. Okay. And we're gonna reduce all the predictions, and we basically yeah, so we're gonna hey Aya, this is Elixir. We are building a sentiment analysis processing pipeline for a social network which is called BlueSky. BlueSky is like Twitter but better, and without Nazis, and well, mostly, and trolls and negativity. Wow, it sounds wonderful, but it's just whatever. It's like Twitter 2-3 years ago, where it was still normal. So we connect to their firehose API, which means that we get all the posts that are being created on the platform. Like lots of events just being thrown at our system, and we handle these events in a pipeline. So we filter these events, and then we run sentiment analysis on them. So for every post, we run it through a model that gives us a like negative, a neutral, positive classification, whether the text is positive, neutral, or negative. And we want to average all these sentiments across time for like a minute, and then we're gonna store it in the database. And that way we have a like a running average, a rolling average, not a rolling average. We have an average over time for the sentiment on the platform, so to say. Not sure whether it's gonna be super useful, but it uses a lot of technologies that I haven't touched before, like Broadway, which is like a pipeline for data processing in Elixir. And currently we already implemented the model here. So we run our sentiment analysis using a model. And now we're at the point where we have the classifications of the posts. So we get back from the model, you know, hey, 15 posts in, 15 predictions back. And now we need to average these predictions and put them in the database. Yeah. So that is what we're gonna do next. And what I'm gonna do here is basically I'm gonna sort the predictions by their score, and we want to do it descending. Okay, and then we're gonna match against the no problem, I understood. And then we're gonna match against the label here. Can actually get the hat. Yeah. So actually, I'm a big fan of having just variables that give you some inclination about what you're doing instead of pushing everything into a big case or if statement. So this one is here top score, so to say. And now we can check. So if it's label, actually we're gonna do just like this. So if it is positive, then we're gonna add a +1. If it's neutral, then we're just gonna return the accelerator, the accumulator. And if it's negative, then we're gonna return a -1. Neutral, positive, neutral, negative. Yeah. And yeah, eventually at the end, we need to get that result and divide it by the number of posts. Yeah, and then we should be getting an average. Let's see. Oh, I forgot to close. Function, this is closing, do this one. So okay, yeah, so now we get values for the average sentiment of the like 15 posts. Interesting. They're all between like 2 and -2. The results. Is that what we want? Why don't I see something like 15? Well, if all of them were positive, I would see a 15 divided by 15. That should be 1. So I think we're making a math error here because we have values above 1. That should not happen. And likewise, we should not see something smaller than -1. Okay, let's check our data, our math here. I'm dumb. I'm also here. I'm also printing out the time. So half of this is actually not our results, it's actually the time. That's why I was confused. Yeah. Okay, so we're getting like -0.13, -0.2, -1, 0.2, 0.2. Yeah, that looks better. 0, 0. Okay. Well, then the last thing we need to do right now is kind of like a dumper. So I'm calling this dumper because we're dumping the values into the database. And I want to dump the values. I want to like aggregate the values for every minute. And then every minute we dump them into the database, creating a new record. Yeah. So I'm gonna create a new GenServer for that. I'm just call it dumper. Actually, sometimes no. In Visual Studio Code, there's a pretty cool extension library where you get snippets for Elixir, and you can just say, "Hey, generate me a GenServer." And then it generates you the whole like boilerplate for a GenServer. But unfortunately, that doesn't exist yet in Z, which is the thing I'm using here. So we have to write everything ourselves. And whole code for it. It's on GitHub. I'm gonna show you in a second. It's here. I had to write it wrong, but it's called BlueSky Firehose Sentiment, and it's under my GitHub at PJ Ulrich. So you can find it there. Wait, maybe I can actually post it here. No, I can't. I can't post in the chat. Just look for PJ Ulrich and then Firehose and you will find it. Alrighty. Okay, so we have our init here and I'm gonna ignore the arguments. And our initial state. Yeah. So what I want to do is it's not going to be super accurate because I'm going to wait for like a minute and yeah. So my problem right here now is like, I'm over engineering here, but my idea is like, how can we kind of, how can we make sure that we actually dump every minute into the database? You know, we could just do a process send after, and then it's gonna be approximately every minute. It's gonna like have a little variation of a couple of milliseconds. But I think what we can also do is kind of like if it's around 1 minute, it should be good enough, I think. Yeah, but if you have a better idea about how to schedule something at exactly 1 minute, but I don't think we can do that. So basically, the state that we start with is an average, and yeah, an average. And I'm gonna schedule a dump. Yeah, I don't know. I don't want to. Yeah. So the reason for the 1 minute aggregation is that I don't want to just store millions of values in timescale. It doesn't make sense. We can rather handle it in the application where we just aggregate everything for 1 minute, and then every minute we dump it into the database. So we actually only have one record per minute. And I mean, that is still like, what, 3,600 minutes a day? I think that was my guess. No, that's second. 1,440 minutes. That's approximately what I said. That's how many minutes we have today. So per day, we store 1,440 rows in the database, which is fine. Like, you know, after a long time, it's going to be up to the couple of 10,000s, but that's fine. But if we wouldn't do it, you know, we actually, like every second, we would have a new value that we need to dump into the database. So it would be a bit too noisy, which we also don't really need. So I'm going to schedule a dump. Send after self. Every minute. Wait. This needs to go here. And the message is just gonna be dump. Then we need to write a callback. And yeah, right now I'm just gonna print this out. Right, yeah, we could let Timescale handle it. That's true. We could do it, but I don't know. Yeah, let's look at it later. Let's first do it this way, because eventually we could also use Timescale for aggregating like hourly and daily metrics. You know, that would also be good. But I don't see a reason to dump like millions of rows into the database where we just need like 1 minute precision at max. Yeah, but we will also get into that. We will get into the resolution, like the aggregation part. We will do that for hour and days. Yeah. Yeah, actually, I need to take two things. I need to have a running average, and I need to have a count. Because like if we just aggregate the if we just send averages here and we just add averages, you know, to the running average, we don't know how many counts we have, so we don't know the average per minute. So that's why we need to have the count and the sum. And that gives us the average. So the sum is 0 and the count is 0 when we initialize. Well, and yeah, we also want to have a helper function here calling just push. I'm gonna call this push, and our sum and the current and the count. And I'm just going to be a cast. I'm just going to call this add. This is yeah. And we need to handle that. And basically we just add the new sum to the sum and the new count to the count. And that way we are like we're aggregating over the entire minute. We're aggregating over the entire minute, like the total sum of that minute and the total count. And that way, if we dump it every minute, then we calculate it correctly. And here's a little caveat. If you ever need to schedule something, and you have in your handler, like in the callback of your scheduling thing. So you schedule something and then you handle, you know, that like schedule when it happens. And what a lot of people do is, well, not a lot of people, but the pitfall here is that you might handle whatever you need to do, and then in the end, you might call schedule dump again, right? Actually, this is a handle info, no reply, and yeah. So you might do this, right? Where like here now we would put everything in the database, and only then we would call schedule dump, and then we would return the result. The problem with that is that you have a, what's it called, a time, you're moving the window of the 1 minute always further by the execution time that it takes to dump something into the database. Because you schedule something, then you execute whatever you need to execute, and then you schedule the next one. And so the execution time shifts. I think it's called a time shift. It shifts your window further every time you execute something. So what you need to do is you need to schedule before you execute. Otherwise, you add the execution time to the scheduling time, which you don't want. A little trick there. All right. Yeah, so this seems to be good. I'm just gonna set this to like 10 seconds so that we can actually see this happening. Right, yeah, well, of course, we also need to start this thing. And in our thing here, we need to rewrite this. And we need to add the sum and post. All right. Okay, so now we should see every 10 seconds a response. Okay, there's a dump. Where is my logger? Okay, that's a bit better. All right. Yeah, and that's our dump every 10 seconds. So I guess the next part actually, so yeah, here we have a dump of 2.0 is the sum of 62 posts, and that gives us this average sentiment. Okay, 15 for 107 posts gives us that average. -1 for 106 gives us this one. Okay, now we have our dumper in place. We can set this back up to, actually I'm gonna make this an attribute. So I'm gonna do this every minute. Boom. Yeah. Okay. So far so good. Let me just push this. Ah, damn it. Yeah. Now it should be okay. It's right here. Alrighty, so the next thing we need to do is dump it into the database, and that needs to be a TimescaleDB database. And actually, what is it in Elixir? TimescaleDB? Timescale, yeah, from Davy. So this one, okay, this one is actually useful for querying. Yeah, I'm gonna start a Docker container here that already has the extension TimescaleDB enabled, so we don't need to install it locally. And yeah, it seems to be the case that we mostly use it for querying. So like not the dumping. The dumping is just gonna be plain Postgres. And then for the querying, we can use Timescale. Let's see. Building a health tracker. So they have a repo. Yeah. Well, this is again, this is what I meant. Like maybe I don't know. I'm not 100% sure whether I like that we all move towards Livebook now, because now, yeah, this for example, this is not something you need in a Phoenix application. This is like only setting up the repo connection for a Livebook, right? So it's like, and even the migration, you don't need that either. Yeah. Okay. Timestamp. Right, so we actually need to create a hyper table, which is, I guess, on top of the existing table. But it is also a special migration from Timescale. So you create the TimescaleDB extension. Sorry, can you see this? Here, you create the TimescaleDB extension, and then you also have these creative not exist table, unique index table, create hyper table. Yeah, and then you run the migration. But the rest is just going to be pure repo, like Acto stuff. So we can do an insert and so on. Then, yeah, we can query using hyperfunctions. Okay. Yeah, we can even use a time bucket here for 1 second, 1 hour, 1 day. Cool. Let's do this. Let's, first of all, I'm gonna set up a local Docker, what do you call, this can go away. I'm gonna set up a local Docker container so that we can run Timescale here. I usually use Docker Compose for that stuff. And just give me a second. I have to copy something from another project. I have it running somewhere. 1 second. Where is my Docker Compose? Huh. I can't find it. All right, let's, okay, let me. Yeah, so I'm just gonna, I copied this one from another project. This is for PG Runga. So if you wanna do full text analysis, like full text search very quickly, you can use the PG Runga extension, and that makes it super fast to do any like multi-language full text search in Postgres. It's incredibly fast. So this, we can reuse this Docker Compose for running the TimescaleDB, because what we need is TimescaleDB. Latest PG16. Our tags are, well, we need to do this one. And then just do latest PG16. PG16. And usually, yeah, that should be it. Postgres password, let's see. Docker compose up. It's pulling the image. Yeah, and while it's pulling, I'm just gonna do a quick stop to the bathroom. Oh, failed. It's already allocated. Yeah, I need to stop my current one. Oops. I already have Docker running. Let me just stop all of those. Okay, and now we started. Yep, looks good. Okay, just give me a second. I'm going to be back in 2 seconds. All right, how's everybody doing? Are the people still there? Still watching? Let's see. One person on YouTube, one person on Twitch. Very good. Many hundred people on Twitter. It's just so broken. Okay, so I think we're ready to add our TimescaleDB now. So we have our Postgres running, I believe. Let me check here. Yeah, looks good. Looks to be running. Now I'm just gonna generate Phoenix gen context data points. And it's gonna have an average, which is gonna be a float. I'm gonna make this a decimal. I'm gonna make it a decimal. No, it should be a float. And a sum, which also is a float, and a count, which is an integer. And then we don't need to have special timestamps because we can just use the inserted at timestamp. Okay. Let's see. But from TimescaleDB, we learned that we need to create a different kinds of migration here. So let's have a look at the migration. So create if not exist. Add, yeah. Do we need an index? Not really. We don't really need to have a primary key. Yeah, we want to have. Well, UTC datetime should be fine, right? Ah, wait. Yeah, we also need to add it to our application first, of course. So timescale. The latest is 011. Is anybody still out there? People still watching? Just give me a little heads up. Yeah. And we want to create a hyper table for data points and timestamp inserted at, yeah. And we also want to create the extension. Well, do we need the extension? Let's see, because we already have it enabled. Still watching. Awesome. Hey, John. Hi, Kevin. Thanks for staying with me. Grading for the grand finale. Let's see. Yeah, I mean, now we're just storing everything, and then it should be easy to put it into live view. Right? What we could also do is have a pub sub, and then whenever we insert a data point into the database, then we, you know, look in like in live view, we react to it and just show it in the like in a graph or something. Would be cool, right? Maybe let's do that, because we also need to wait until the whole thing here like loads some data. So let's do that. Yeah. But first I need to drop the tables and the extension, and that would be this one. All right, let's see whether I can migrate. Does not exist. I need to first create it, of course, and migrate. All right. Create extension if not exists. Timescale already exists. Okay, skipping. Create table if not exists. Data points. And we created a hyper table as well for inserted at. All right. Now if we go to data point, we still need to disable the primary key. And yeah, so we have the average, we have a count, we have a sum. Cool. So now in our dumper, right here, we can call data points and create. And yeah, what we want to do is just average. That should be the sum divided by the count, the sum, and the count. Okay. Now let me just set the interval here again to 10 seconds so that we can actually see that something is happening. And let me open Postgres. So now we have Postgres here. And in our data points, we already have a data point. Should we? Yeah, we should have a data point. It already ran for like 10 seconds or so. So, and we also see that we have now 2 data points. And we have an average, we have a sum. Oh, the sum is not a float. Did we make a mistake there? Well, I mean, in this situation, because it was a 3.0, I think maybe that's why it didn't store it as a float. Yeah, but if you look at the structure, we see that our sum is a double precision float, so that should be fine. I guess it's just how it's shown here. I'm just waiting for a sum that is not a normal integer, because we might also make a mistake there. Like when we add the integers together, are we maybe, or the floats, are we maybe missing like some part there? Still waiting for something like 0.7 or so. 0.0, they're all 0.0s. Why is that? Well, what happens if you add a float to an integer? It stays a float. I guess this is just... But it's weird, no? Like, why is it rounded? Let's see, maybe we make a mistake here. Yeah, I mean, this, what we return is a integer. So what happens if you add an integer to a float? Does it become an integer? No. Well, yeah, of course. I mean, if we only have integer values for our sum, like here, right? Because we don't take the float predictions, we convert them to like 1 - 1 0. So of course this is always like an integer. Yeah, we could have made this an integer too. But it's okay. I'd rather keep it that way, because if we eventually decide, oh, we actually want to use the sentiment here, like the real prediction, then we can always change to a float. But we can never, we can change from a float to an integer later, but never from integer to a float. Well, we could, but then we need to migrate now. Anyway, it's fine like that. It's fine. It's fine. We got a bunch of data here. We get some nice averages. Yeah, I'm just gonna keep it at 10 seconds so that we can gather some data, but this seems to be working fine. So what I want to do now is I'm just gonna create a live view where we can can I only create a live view? Never mind, I can just create it myself. So I'm gonna create a live view where we can actually see just like a graph of the data. Yeah, dev module. And yeah. So amount, let's do it in mount. Param session socket. So if we would just wanna create a stream here. I always forget how to do that. There. Yeah, so name items, we can already add some items there. Yeah. So if the socket is connected, we get some data points. And if not, we just have an empty data points here. So we're gonna call this data points and items. All right, and then in here we can create our stream. I always forget how to do that either. It's just a list, and then we have to do the update to stream, I believe. Whatever. Yeah. So in our data points, so we're gonna have like just add the, well, this should be a table. I'm not sure how that works with tables. Let's try a table. And then this should be a table row. And then we can add the data point average. And we can create the just sum and count and the inserted at to see how that looks like. Yeah. All right, let me just restart. And then we should be able to see it in Firefox. Oh, we're getting an error. If you would like to expect the stream data points to be a struct or map with an ID key. We don't have primary keys. Yeah, we should have primary keys. All right, let's redo this. But then we need to, yeah. But that makes it easier to show them because then every data point has an ID. So we need to add a primary key. And also here we need to rerun the migration. Yes. Oh, yeah, we're using it in Postgres right now. Boom. So we need to drop it and set up. Cannot create a unique index without the column inserted at. What is happening here? Just drop again. Let's create and migrate. Once. Okay, we're getting an error here. Cannot create a unique index without the column inserted at used in partitioning, and there is a nil. I mean, do we still have data in there? I don't believe so. No, it's just empty. I think there's no table right now. So why do we need to add the ID here somewhere? Let's check the examples. Oh, I might, yeah, that's right. The hyper table, yeah, that's right. How do I drop the hyper table? Heartbeats, mode cascade. Yeah, I mean, in this situation, they don't have a primary key for heartbeats, but a timestamp. Let's see, maybe with mode cascade, maybe that will delete the hyper table as well. No, same mistake. Okay, let's have a look at the hyper table function in the migration. Create hyper table. Creates a new hyper table in active migration. All right. The Postgres table cannot be an already partitioned table. Do they have a drop hyper table function? Because yeah, you're right. Maybe I need to drop the hyper table. Ah, no. Drop timescale extension. Drop toolkit. Wait, let me check Postgres again whether, because it should be a separate table, right? Here. So I see a TimescaleDB cache, catalog, config, debug, function, internal, experimental information, and that is it. There's no particular table here. I mean, what happens if we disable the primary key? Maybe the issue is the primary key. And then we can just find another way of doing this. Data point. Let's see whether this now works. Yeah, it does. Interesting. So what, it cannot have a primary key? That's weird. Create hyper table. So what happens? it can, so the Postgres table cannot be already partitioned. All right. In case of a non-empty table, it's possible to migrate the data during the creation using the migrate data option, although this might take a long time and has certain limitations. I mean, maybe, but there shouldn't be any data in there yet. Returns. I mean, we can try migrate data. So yeah, now we don't have a primary key. Primary key false. Wait, no, we need a primary key. What am I doing? We need a primary key. Okay. So I'm gonna drop. And I'm gonna set up. No, didn't work. Create a unique index without the column inserted in. Used in partitioning. What? Well, okay, well, let's just give it no primary key. And what else can we use as an ID? We can use the inserted add as an ID, but it's not great. Yeah. Yeah. You can convert this GMT as a timescale ID. That's what I thought too. Let's just do it like this. I'm gonna make a note of this. Wait, where's my... Oh, I can't make a note. Somebody make a note of this. I can't make a note. I don't have my notepad right here, but I would like to ask Davey, like I know him, the creator of the language, of the here of timescale of the library. I would like to ask him what's the issue? Why doesn't it work? Because yeah, in this situation they also, what do they have? Yeah, they create a with primary key fault. So does he say anything about the ID or primary key? No, doesn't say anything. I will ask him. So for now we're gonna have no primary key, but this should work now. Yeah, we don't need to do this. Okay. All right, let's start the thing. Let's get some data on there. And in index live, oh yeah, we can actually set the ID here. ID. That way we're gonna have an issue there again. What was the issue? Yeah, expected stream data points to be a struct or map with ID key. Got the data point without ID. If you would like to generate custom DOM IDs based on other keys, use stream configure. Yeah, that's right. We can use stream configure with the DOM ID option beforehand. We can do that. And where is the stream configure? Here. So that one is gonna get the name and some options. So data points, and then we can generate the DOM ID, and it's gonna be a function. So data point. Maybe we just do this toString. I think that should give us a DOM ID. Not sure whether I need to call this before or after I create the stream. Let's see. But I think it was before. All right, seems to work. Okay, look. Now we have a super ugly table. Let me just make this a bit nicer. So, oh, actually, I don't care. I don't care. But the inserted head could be here. Just a bit more space. Hey, Tiago. Yeah. Well, Tiago and I used to work together. And it's fun. Yeah, we never really paired that much, so now we're pairing kinda. Yeah. Well, I'm talking to a camera and you're ignoring me, so fun. Alright. Man, I'm just gonna go to Tailwind UI and get a nice looking table there. Oh, hang on. Yeah, honestly, if you don't have table UI, you're missing out big time. It is the best money for value that I've ever seen. Table, where's the table? Table, there. And we want to have like this one. Okay. Okay. All right, how does that look? Ah, already looks better, huh? Slightly better. But we can rename this. Is not name. This is a timestamp. This is the average. This is the sum. And we have a count. Okay, and we can add all that stuff here. And we can remove the add user and stuff. Okay. All right, looks better. Do we have a max width there somewhere? Yeah, we don't want to have the max width. We want to be super wide. There we go. Oh, wait, sorry. I had the privacy thing on. I'm sorry about that. I was just pixelated table looks good too, right? Yeah, now like out of a sudden, just poof, I didn't do anything. Out of a sudden it looks super pretty. I stared at it very intensely, and out of a sudden it has a pretty view. So yeah, now we have a table. Wow. I'm gonna make it a bit smaller. Just like a max width for Excel or something. And order. There we go. Yeah, cool. All right, now we have a table. I'm gonna also set up pub sub so that we react to new data points. In the create data point endpoint right here. And then I'm gonna do broadcast. And if we receive a data point, man, I always forget this broadcast. Yeah, to, what is the name of our pub sub? App pub sub. Pub sub, and then the topic is new data point, and the message is data point. And then I'm gonna return the data point too. And if we get an error, I'm just gonna return the error. Okay. Can we add a chart? We will add a chart momentarily. I just wanna set up the PubSub first, and then we will add a very nice EChart. That's what I love to use. Yeah, I tried out Vega Lite, and I don't know. Yeah, it's used in LiveView, and not LiveView, in LiveBook. But I think they also use it from Vue, not from Elixir themselves. And I don't know. I don't like Vega Lite. I tried it out. So many options didn't work. Many of them just broke. It was very hard to design the thing. So what I love to do now is I use ECharts. It's from Apache. Not Apache. Yeah, well, Apache. ECharts. Boom. Here, free to use. It's super amazing. It looks really, really cool. So what we want to do, for example, is like a horizontal confidence band, maybe. Let's see. We want to have something that oscillates around 0, right? So that's a function plot. No, not bar chart. I think we can use something. We can probably use this one here. No, that's a double chart. Here, the confidence band, maybe. Like if we just set that to -1 and 1, and then we have some oscillation here. I mean, look at how beautiful this looks. You can just like, you have like an error, labels. The labels are great. And it's just, they have so many customization things. If you say, well, for example, in Vega Lite, like the pop-up label, it often goes outside of your container and then is cut off. And then ECharts, they're smart enough to, calculate how much distance they have between the container and the label, and see when I reach that distance, they just move the label. And they do that automatically for you. And you don't have to do anything yourself. And it's just like stuff like that is making it invaluable. Yeah. Also, you can very easily format these timestamps here down there. Everything is really, really cool. Yeah. All right. Anyway, enough about that. So first, context. Yeah, context for server-side render charts. And it's also, I'm not sure. Like, I saw some code that used it, and it wasn't that amazing either. I don't know. It's always about the customization, It's like, for example, ECharts does these calculations for you, where you put the label, the pop-up label or something. And in context, I think you need to really position everything manually. But then if you have different data sets, it might not fit anymore. Yeah, I didn't have good. I mean, I replaced context with ECharts in an application, and ECharts, at least for browser rendered charts, it was really, really good. Yeah. Yeah. Anyway, so I would say let's first add the PubSub thing here, so that we can just handle that stuff. PubSub, subscribe, that pops up, and the topic. And I think we need to have a handle info, right? For that, handle info. And what is that, like data point? Man, I always forget that, the API here. What is that? Broadcast. Let's find out. Phoenix pops up. Messages. Okay. Broadcast. Yeah. Usually we make it a tuple. So this is what we receive here. Okay. Yeah, let's make this a little bit prettier here. Let's make new data point and then make that a tuple so that we can match here against that particular event. So, and what we want to do is a no reply, and we want to stream insert in the data points, the data point. Yeah. So let's see what happens. Oh, look at that. Well, the fun thing is that we add a new header as well. And I think that that issue is because of the ID. It's usually because an ID somewhere it's wrong. Any console? No. Yeah. Let's see, we have a table with an ID, update stream, then we have the T head, T body, and then the... And setting up the streams is so difficult. Where's the... Maybe we need to add an add. Stream insert. What are the options? Add and limit. Yeah, by default it's appended. Well, not the table needs to have the update stream, but the table body. I think that is the issue. Let's see. Yep, that was it. Always the parent container, not the like table container. Oh, the parent container of the stream needs to have. Yeah. Very good, Brandon. He got it first. I didn't see it. Sorry, I didn't see your message. Okay. Well, now we have updates here. We get all the information in. That is great. And now we can add our beautiful chart. So what we need to do for that is first to install it. So I'm gonna go into the assets, save, and then I usually ECharts. Okay, and what we need to do is we need to create a hook. I'm just gonna create it right here. Nah, I'm gonna make it nice. I'm gonna create it EChart. Man, what is that again? Like this, right? Mounted. All right. And let's look at the examples because usually they have a full code here, this one. So we import ECharts and then we create a chart when we are mounted, we can just do this L for element. Now we have a chart. And then here, these are the options. X-axis. And usually I want the title. But I think we can also add the options right here. Yeah, I'm just gonna do set option. Okay, and now in here, we can create our title, the tooltip, the grid, and then the X and the Y. X and yeah, we need to handle our push event there. So I'm just gonna access label data. Well, our X is actually our timestamp, and the Y is just a -110. Yeah, and then we have our series here. Ah man, that was so much easier when I did it last time. Let's do a simple example, because sometimes they can get a little confusing. So let's do this one. That's much easier. So I'm just gonna copy paste this, and then we can check that we have as a valid option. Yeah, and then I'm also gonna do the loading, like when I fetch the data points here. So first we need to import the ECharts here, and then we gotta put that as a hook. Okay, and now we can just above the table, we can create a div here which has a ID and a Phoenix hook, EChart, capital C. Let's see. There is a, oh, we stopped our server. Now there is an error. View crashed. Why? Oh, there was a banded error. Yeah, I'm also gonna give it a width and a height so that we can see it. Ah, there we go. And it's gone. Yeah, that's the other thing. We need to do Phoenix update ignore. Otherwise it's gonna re-render when we remount the live view. Actually not remount, when we mount the live view, the WebSocket connection, then it's gonna it gets re-rendered and then it just breaks. So you need to do an update ignore here. And we're gonna handle all the data updates with JavaScript. And then you can just push to this to the series, to the data series, I think. Yeah. Okay, so let's make this a bit bigger. Ah, look at that beautiful chart. Beautiful. Yeah. Okay, so now next thing is we need to listen to the events here, and then we can push the data. We can push the data from our live view. So let's what should we do first? Let's first handle the push, and we're gonna do that. I always forget that too. Add event listener, no. What is that? Push, Jesus. Push patch, wait, what is that in live view again? It's a push data, push event, that one. Yeah, exactly. So in our live view, we do push event, and in the hook, we do a handle event. That's what we do. Yeah. So in here, handle event. New data point, or just data points. And we get our data. And I'm just gonna log the data here so that we can see that we actually sending the events from our live view, because now yeah, I'm just gonna make a little function here, push data points, and we're gonna do a push event socket data points, and I guess we need points. Yeah, we can just send the data points. Not sure. Oh. So now when we start our live view, we push the data points as an event, and we also push it every time we get a new data point in. So we should actually see that. Oh, yeah, I guess it needs to be a map. So let's make this a map. Yeah, there you go. And there is a error. We don't know how to encode it. JSON encoder not implemented for data points. Yeah, we can do that here. We can just derive the encoder. And that should be it. No. Again, cannot encode metadata from the meta field. Yeah, right. Let's do an only then. So we only return the average, the sum, the count inserted at. Yeah. That should work. Wait. We need to wrap this in a tuple. Now it works. All right, cool. So we receive our data points here, as you can see, as an array of data points. Cool. And first we get 122, and then we get 1, and then we get another 1. And this way we can actually load the data. Okay. Now in our chart, we just need to find out how to set that. I always forget that too. We can actually use IntelliSense here. So chart, append data, that's what we can do. Series index. Let's find that. So series index 0 and then the data. Okay. So the first series, that's the index here. So we can, yeah, we also need to store this chart in our hook. And then because we want to rely on this, we can't use a anomalous, or what is it called, an ES6 function. That's one of the things I know about JavaScript. One of the few things I know. So yeah, we do append data, series index 0, data points. Okay. Let's see what that does. Probably it breaks our thing here. Yeah. This state is undefined. Ah, man, damn it. I always forget how that goes. Yeah, my trick is just I'm gonna make it a global variable outside, and then I'm assigning it to that. That makes it easier. This data, this should be this chart, of course. Sorry, that was my mistake. Okay, that should work. No, this chart is undefined. Okay. This chart. Yeah, you're right. But I don't know. So my problem with the callbacks here is you don't have access to the this of the Phoenix hook. So yeah, I'm just gonna store it outside of the hook. So here, and then we should have access to it from the callback, right? That's my understanding. Yeah, we do. Cool. We do. So apparently we're calling, but our event, like our graph, doesn't know yet how to represent this thing. Yeah, we also need to convert the data into just the averages. We only want to have the averages here. And I'm gonna do that in the live view actually. So averages. Because but we need the average. We need the average and we need the inserted at for the timestamp. So wait. So we need to generate the x-axis by their timestamp, and then the series is type line. Type line is fine. I'm just gonna make this empty for now. Okay, we need to go to the examples. Let's see how they do it here. So in the x-axis, the data, yeah, here we can actually fetch the inserted at. And we can even format it. So you see here they run over the data. But where do they get the data? I think it's just a callback. No, they get it here, data. Well, this one we can do in our callback for the x-axis. Yeah. Pen data. How do we do this now? has anybody worked with ECharts before? With like the x-axis? Yeah, so here we have the x-axis. Then we have data. I mean, I guess we could also just generate the like a time frame, a set time frame. Okay, if type is specified as category, but access data is not specified, access data will be auto-collected from series data. It brings convenience, but we should notice that access data provides the then value range of the category access. If it is auto-collected from series data, only the values appearing in series data can be collected. Yeah, that's okay. We can do that, but look, so we can actually push data that has an X and Y axis thing here. Oh, we can even value label item style. We can define a so I think this might be it. We can define a like just in the data we can define where the X and Y axis is basically. Let's try that. So in our X axis is actually time, and we're gonna remove the data. Y axis is value, could be, and then we keep our data empty. And when we send our data, yeah, we need to do wait, this one is data points, and we need to do a map. And this is a data point. And in here we return a data point, well, what was it? The x-axis, so that's inserted at, and the y-axis, which is the average. Okay, and then we kind of push this in. Let's see whether that works. No. Average inserted at. Is your x-axis data still defined? No, it's not. It's empty. X-axis is empty. Y-axis is empty too. I have an empty line, empty series, and then I push this stuff. But I think we might also need to convert insert that to something like they say here that so when a dimension corresponds to a time axis, the value can be a timestamp, a date string, and one of the formats below. So we don't have one of these formats below. Because it actually looks slightly different. Oh. Like here. I think we just need to remove this Z in the end, and then it might understand it as a timestamp. But it should support this one. So we have a T and the Z in the end. This is what we have, like a time, the date, the time, and a Z in the end. So that should be interesting. I never understand, like I never know whether my mapping here is correct. So let me just print out that one. Because yeah, now we have an array of the first and the second. But it doesn't do anything. ECharts dynamic data. Let's see. Yeah, asynchronous loading. I mean, in this situation, they load it, but they only set the option after they load the graph. What we need to have is something where after the fact. Okay, so in this situation, they actually, after they already loaded the chart, then they use set option again. That might work. You know, we could make our X, like once we have the data, then we can, you know, provide an X-axis and the series data. Dynamic update here. Okay. Yeah, so maybe we need to not do append data, but we need to do set option with the data categories and the series. So let's see. So our categories are basically the data points inserted at, and our values is the average. Okay, and now what we can do is set option, and in here we're gonna set the x-axis categories to categories, and the series needs to have the same format as here, data, values, type, line. So that's what they do here. Data, or x-axis data. And then series, maybe we need to give it a name too. Let's see. Ah, hey, look at that. That looks fun. It is ordered. I mean, already we have our data here. That's fun. Yeah, I'm just curious what happens when we get new data points. Does it actually add it here? Does it still... Oh, there was a bad arithmetic. Oh, our count was 0. Yeah, okay. Well, if the count is 0, then it should be 0, of course. Yeah, let's restart our application. Okay, so we have our chart here. Oh. Hey, it actually received a new data point, but now the old data points were removed. Yeah, now again it happened. I mean, maybe in that situation we need to do append data. Let's just try that, append data for new data points. But not for the original. Yeah, let's split those. So like when we get the initial data, then we want to do this one, set option. But later, if we have more than one, if we only have one data point, then we want to do add append data. So what I can do is like if data length size, how do you get the, so basically if we have multiple, then I'm gonna do set option because that is my initial setting here, and otherwise I'm just gonna do append data. Maybe data length, data points. I am not a very good JavaScript developer, but it seems to work. Well, now we received all of them. Okay, and now we need to do append data in the end. So chart append data, series index 0 data. We just need to have the first average, I guess. Let's see. No, it does something else, append data. It removes all the data here. I mean, otherwise we can also keep that in memory, our data set. Sorry. I don't know. Let's ask Claude. Okay, so what does this do for us? Oh, it gets the current option. That is smart. And then it gets the current categories and values, and it just appends. Oh, all right. Thank you, Claude. Let's see how that looks like. Well, okay, we have our initial data. And when an update comes in, I don't see anything. Well, there was a new data point somewhere. I guess it orders the data points. I don't want that. Okay, well, at least it doesn't overwrite the data. And yeah, I also in here I want to say this uses ECharts. Okay. Right, now it shows -1 to 1. Cool. And I also want to disable the sorting of the data. Sort data false. I think I also need to do that here in this series. Nah, it still does sort data. Well, maybe we need to manually sort it. Sort. No, I'm not sure. Nah. All right. Well, thanks for coming along. Sorry, this is a little bit frustrating, but yeah, thanks for stopping by, man, and see you next time. We are getting closer though. But here, look, I think the issue is that it doesn't pass our timescale data because they all have the same timestamp. I think that is the issue here. Yeah. So it does not. I guess it. I don't know. What are the type X? X-axis. No, it still does not. Yeah, so this person here, for example, it has the same, like they have a couple of dates and they have some issue there. So in this situation, they have a lot of, yeah, like inserted at and then a number. And they do have a time date, and then they also have a axis labeler. So let's maybe reuse that idea. Oh, they use moment. Nah, I don't want to use moment. Ah, that's okay. Item style. I mean, they put it to a type time. I would expect that they're smart enough to load these things, but somehow they're not. Look, they all have the same timestamp. Well, thanks for subscribing. Appreciate it. Yeah, if we could just fix this, I'm gonna ask again. So wait, what are the new categories? Maybe we are doing something wrong there. No, but the categories all have proper timestamps. X-axis time. Yeah, here, this is also again interesting. So they don't give the categories in the x-axis. They have this two-dimensional array. I want to have the same. Why doesn't that work? And that works fine. And it is using ECharts. Are they using ECharts? Yeah, in ECharts line. It should be smart enough to understand that, right? Yeah, let's try this one. I mean, that should work. All we need to do is to have an x-axis of time and then y-axis of value with a min-max. Okay. Now, next, symbol timeline. Data points have x-y relationships. Well, the issue of that is that it doesn't, like here, see, I can actually look at every data point, and it does not correctly pass our timestamp. You see, all of them have 1970 or 101 as a timestamp, and that's, I think, because they all have the same timestamp. Like ECharts puts them all in, you know, one category, and then it sorts it. That's why it looks like this. I think, yeah, still the issue is somehow that it does not properly pass our timestamped data. So that's what I want to do here. Let me just, yeah, I think we just need to do data point. I think we need to insert a two-dimensional array. I hope that will actually somehow work. Data points. Okay, so now we have new values, and yeah, we actually just do this. Current values. Ah, look at that. That looks better. That looks good. Well, at least like here now it sorts our data according to the timestamp, and then yeah. I mean, we have some breaks here. Probably where I restarted the app or something. Also, they're not all correctly sorted. Maybe I can do sort data. True. Yeah, that still there are a couple of ones where they go back and forth. I mean, I can also sort the data, but wait. ECharts, series, sort data. Turn series data amounts ordered. Yeah, they order it themselves here. Yeah, okay, let's sort these manually. Wait, sort. Okay. Let's see. Yeah, that fixed it. Now we don't have these data points that are like zigzag. I mean, yeah. Do we learn anything from this data? I would say the sentiment is pretty much neutral. Yeah, I don't know. But we do have... I mean, we have to take a step back because honestly, we just finished the whole pipeline end to end, didn't we? Hello. Yeah, I mean, okay, so what did we do? Let's recap, right? We connected to the BlueSky firehose API. Actually, we didn't connect it to it directly. We connected to an easier API, which is called Jetstream. It's a simplified JSON event pipeline for the BlueSky. So because we originally connected to the real API, hang on, what do you say? We have struggled with pretty charts versus powerful mappings. For us, ECharts and Chart.js versus Vega Lite. Vega makes us work to be good, to be good UX, but the mapping is powerful and vice versa. Can't seem to have both. Yeah, I guess. Vega Lite is very much, I don't know, for data scientists, I guess, right? I mean, ECharts is more for consumer-facing, client-facing stuff. That's what I need to do. But yes, Kevin, we did it. You watch. No, you helped too, Kevin. You gave me the ideas. You helped me actually with the EXLA backend. Only because of you, I managed to get it to run faster than like 1.5 minutes. So thank you very much for that. Much appreciated. So yeah, I mean, let's recap. So we connected to the BlueSky Jetstream API. We connected it like to our local application. And now we get a bunch of posts every second. You know, I think on average there were like 60 posts per second. I saw in some graphs there. We will filter those by their language. We only take the English posts, and we use Broadway for that, for the pipeline. Then we batch them into batches of 15, and we run that through a model, BERT, a machine learning model, to run the sentiment analysis on each of them. And then we average all of those, And we store that in TimescaleDB every single minute, or in this case, actually every second. So I'm actually thinking if we would now move away from 10-second intervals to 1 minute intervals, maybe that would be more like, you know, it would become a bit more stronger, or it would actually even out. It might average out, you know. So I don't know. But yeah, now we store it in the database. I mean, we use TimescaleDB. We haven't used it yet really to do any meaningful analysis. We could still do that though. You know, add some averages here, show the last, you know, 5 minutes average or something. And you can see sometimes you can see actually a new data point popping up there. You know, that's our new data point, which is exciting. Yeah, but I think as a last, so I don't know, what do you think? Should we also deploy it to fly, see how that works? And then we also need to figure out how to do the connection to the GPU actually. Do we? I mean, maybe we don't need a GPU. Maybe we just yeah, maybe we just like run it on a powerful CPU, because I'm running it on a powerful CPU here. I mean, it's just a MacBook, and it's fast enough. Like it takes a second, you know. So it's funny. It's funny to just look at these dots popping up on the right side. It's kind of soothing. And another one. So what do you want to do? I think that two things we could still do. One of them I think would be interesting, which is to use TimescaleDB to do some averaging now. So we actually say, hey, look, calculate the average sentiment over the last 5 minutes, you know, like just to see how this averaging thing works. And then we can show it here in live view, you know. And whenever we get a new data point, we just update that thing. And that way, you know, I mean, in this case, the average would be 0 pretty much. I'm pretty sure of that. But it would be fun, right? Let's do that maybe. Let's write a query for that. Shouldn't be too hard. We just need to go into the intro to timescale. And oh, look, yeah, that's funny. My name's actually in here. Why is my name in here? That's funny. Yeah, I helped Davey. He gave a talk about this at ElixirConf, I guess, and I reviewed his whole talk before he gave it. So my good friend Alex Kutmos is here too, and Dave Lucia. Alex also reviewed that talk, so I guess that's why Dave added our names here as an example. That's very nice of Dave. Thank you, Dave. Yeah. Okay, so let's see. We have a first and a last, and we want to do the time bucket. Well, that's only how we bucket it. We want to do an average. Here. So we can use a time bucket hyperfunction to calculate average BPM for each hour. So in this situation, we just do a query here, and then we use the time bucket function. And the first item in each tuple is the actual timestamp of the heartbeat down to the microsecond. The second item is the result of time bucket on the timestamp, bucketed down to the nearest second. Okay, so in this way they bucket all the heartbeats that are per microsecond into buckets of second. Okay, so it acts like a floor. So when you have, you know, 100 milliseconds, you floor it, and then it's like 0 second, and 1.1 second would be 1 second. Yeah. Oh, look, we can just do a selected as, and that way we can actually select by the minute. And I guess that gives us the average. Let's have a look at that. Modules, timescale, hyperfunctions. Time bucket. Toolkit. What is a roll up? No, that's a candlestick. Where do we get selected? Okay, so we need to look at TimescaleDB selected as the time bucket function is similar to the standard Postgres date bin function. Unlike date bin, it allows for arbitrary time intervals of months or longer. The return value is the bucket start time. Yeah, we do not want that. We want to have a an average. Where do we average? Averages. But time-weighted averages and integrals. It would be nice to overlay the count as a separate line to show how many posts we have processed of that given timestamp. That's true. Let's do that first. That should be a quick one. Yeah, because we have two series here. Series name. So the first one is the average, or just average sentiment, and the second one is the post count. Okay, and in here we can current averages, and then we also do the current counts. Yeah, and new values should be new averages. And then we also need the new counts. And it would be count. Alrighty, and now we can just do this and do the new counts. Oh, let's see. Post count. Well, so the problem is our y-axis. We should have a second y-axis, because like one y-axis from -1 to 1 and the other one is 0 to 200 or something. So how can we do two y-axis? Here. Yeah, we have two y-axis. So let's also do that. Wait, we can just make this an array. And we remove the min-max, and now data and data. I don't know, does this do something? No. Post count. Maybe we need to name them so that it can match on the name. I mean, what happens if I just remove the min-max here? Well, that's what I meant. Like we have one that is at hundreds and one that is at 0 point something. So that's why we need two y-axes. But where is it? I mean, this is an example, right? On the right side we have rainfall, on the left side we have flow. And left side is flow, right side is rainfall. Okay, and then we have a, there's just one series, data, okay. And then the second series. Timeline, y-axis index, that one might be it. And this one has y-axis index 0. Ah, look at that. Beautiful. Wow. Do you, maybe, I don't know, can we smoothen? Do you think it might be interesting to smoothen that? Because also here you see, you basically see nothing. It's just so many. I would, can we smoothen them? Yeah, I don't know. I'm not sure whether ECharts allows us to smooth. Smooth line chart. You can just smooth true. Let's see how that looks. Not at all good. Yeah, that's why, like, every 10 seconds. I mean, you know, what we could do here is, well, I mean, here's where we could use TimescaleDB to like bucket this by the minute, and then we have, you know, not every 10 seconds, but every minute or so. I'm just thinking, how would we handle the updates of the single events? Let's see whether I would ideally I would like to do that in ECharts, but let's see. Sometimes I have like a average series data, but you need to calculate it yourself. We can mark line type average. Oh. Let's see whether we can add like a average. Ah, look, we have an average line. Wow. Does it do anything? Yeah. For the, what's gonna do it here for like, yeah, orange. Okay. Well, better than nothing. Wait, that's too big. So we have an average of 107 counts, whatever that means, over all these elements, I would say. Let's see, maybe we can make the average line a bit more API handbook. Average. Maybe we can like say, hey, only do that per minute or so. Mark line. Action timeline? No. What's this? Series, right? You know what? We could add that line with TimescaleDB. So we don't use ECharts for this. We calculate the values with TimescaleDB. And then we just push the values to the front end, and we show that, you know, as an extra line or something. Maybe that would be easier. Let me just close all of that stuff. Oh wait, I need this one. So first we need to do the time-weighted averages. And I just want to have the query. I don't care about the blog. Okay, how to compute it. Thank you. We have a bunch of information here. Okay. And now what they do is well, they calculate it manually. That sucks. I thought timescale. Yeah. Hyperfunction to the rescue. Thank you. Yeah, we just select. Okay. We select an average of the time weight in linear. But how do we do this per bucket? Here, this is in every minute. This is what they do in every minute. Every minute or 15 minutes? 15 minutes. So they calculate the average as a rolling average over a window. Might be difficult to do that in Elixir. Well, we can use a time bucket and then we run the average on that one. We can do that. I thought that might be easier. Like they could have done that easier, but I don't know. Like what do I know? 15 minutes as petition. Freeze ID, timestamp. All right, let's just copy paste this and see whether we can rebuild it. So in here, we want to list, we want to get the get average per minute, basically. And what we need to do is we need to rebuild this query for our data points. Let's see whether we can do that with timescale hyperfunctions here. Well, they do have a roll-up. Here. For example, you can use rollup to combine candlestick aggregates from 15-minute buckets into daily buckets. Timescale. Let's see, are there more examples somewhere? Continuous aggregates. Aggregating data over time is extremely common when working with time series data. Often you want to compute aggregations across your data sets. Yes. Group by various attributes such as users, location, and of course time. TimescaleDB has a feature called continuous aggregates that dynamically improve the performance of expensive aggregations. It accomplishes this with some clever usage of materialized views, triggers, and hypertables. Okay, let's build a continuous aggregate for calculating the min and max daily BPM for each user. But we don't necessarily want to have a materialized view. But what we can do is, well, they select a time bucket as minute and then the count of the BPM from heartbeats. And then they query on that for an interval. It's not quite what we want. But already the select time bucket, I think that might be what we, well, I mean, this situation, they literally just use Postgres query, so if we just write it like that. But I thought they would have some, you know, actor-like queries, because we can literally do this, I guess, or repo query. Actor repo, does it have a query function? Or we just execute a query? No. How do we just query something with just a string? Like where we just, is it a fragment? No, but a fragment. So what I want to have is a function where we literally just execute a query with Acto, but using the repo. So I don't want to Acto repo functions. They're non-user callbacks. No. Query API. All. Oh. How to use raw SQL with Acto repo. Oh, okay. So you can use Actor Adapter SQL query and then insert your repo there. Yeah, so that's... Okay. So Acto Adapter SQL query repo and then the query. But yeah, of course, now we need to replace this with data points, partition by TS. And 1 minute. So, I mean, if this works, we select the average time waited over the 1 minute window, which is a partition of our whole data points table per minute. I have no clue whether this works. Let's do add data points, get average. No. Function time way does not exist, but unknown. Timestamp, double precision. The linear. What was it? Time wait. Time wait linear does not exist. Yeah. But I don't particularly care about the time wait. I just want to have the average. Okay. Well, we're getting closer though. We're getting closer. So let me search again for average sum. Stats aggregate. Perform common statistical analysis such as calculating averages and standard deviations using this group of functions. Okay. Aggregate. Stats ag. Okay, so that's a function, and then we can access the average, for example. Here. Do they have an example? Here. Extended example. So with time bucket 1 day of the timestamp, you calculate the stats ag of that. And then you select some stuff from it. Okay, let's try that instead. That might work better. Yeah. So I'm just gonna do this. And then we can select everything. Okay, so time bucket 1 minute. Interval inserted at. Yeah, stats aggregate average. From data points. Group by 1 minute on the inserted at. Stats ag double precision does not exist. But that's exactly what it expects. Double precision. I mean, maybe we're missing the timescale. They say the functions. But I mean, let's just, I don't know, take this one out and just return the time bucket. Okay, so it works. So we get the time buckets by the minute. Yeah, that's good. And well, the next thing is that average. Next thing is the stats ag does not exist. Did I stats ag? This is harder than I expected, honestly. I thought TimescaleDB would be just as easy as Ecto query, but no, it's not. Freaking hell. I mean, I need to, like, you know, write raw SQL. I mean, maybe the library offers that, but I didn't really see it. Like, there are hyper functions here. And then we have like a first, last, time bucket. I mean, that's okay. VREP, but I want the average. I mean, they have like a roll up. Candlestick. I'm not sure what that is. Perform analysis for financial asset data. This specialized hyperfunctions make it easy. I guess Dave just didn't implement all these functions, which is fine. But yeah, right now. Maybe just the average. I'm just gonna calculate the average instead. Average does not exist. I don't know. Maybe my timescale thing doesn't have all the functions that I'm expecting. Oh Jesus, almost 9 o'clock. Yeah, I think we should wrap up here. It's been a while. Yeah, it's been a very long stream, I guess, today. But yeah, so actually, I don't know. We got really far, to be honest. I'm impressed. I'm impressed with us. You know, we did a big chunk here. We finished the sentiment analysis. You know, we got the model to run locally. It's fast enough on the CPU even. We run all the posts through it, and we get all the data back, and we aggregate it, and we store it in the database with TimescaleDB. Now we just need to query it properly, and TimescaleDB there's a little tricky. But yeah, honestly, this is cool, no? Like, we got really ahead. Yeah, I'm gonna spend one more day on this. I think next time when I do a live stream, probably on Thursday, I'm gonna do one more round, and I want to finish the TimescaleDB queries. I want to figure out why the heck that is not working. And then I want to add like a per minute, or like, yeah, a per minute, like a smooth line here, right? Because these are per 10 seconds. And I want to have a per minute smooth line. Yeah. And then maybe we deploy to Fly, see how it works, see how it starts up and all. Yeah, definitely, Kevin. Me too. It's 9 p.m. here in Amsterdam, or Netherlands. But then, yeah. Well, anyway, thanks for joining me today. I will be back on Thursday, and then we finish this one. And then next week we're gonna start with a new project, which I am extremely excited about. Which is we're gonna build a Twitch clone, and we're gonna use Membrane and Boombox, which is a library for audio and video processing in Elixir, and we're gonna create our own SMTP, I think, stream, which is like a live stream for video and audio. We're gonna host it on our website. I'm gonna add a chat thing there so that you can chat with me, you know. And the other thing, I still want to use AI. So I actually thought about like how can we add AI to that. And what I want to do is like during the live stream that I'm gonna host on that website that we're building together, I want to run Whisper, the Whisper model in the background, and it's gonna listen to me talk, and it's gonna transcribe my talk, well, more or less in real time, and it's gonna show that on the website. So maybe we are, you know, exploding the scope of this, but I think that would be a really cool thing where you can see me on a website, like right as you do now. But you can see the video, the audio, the chat, and then you can also see the transcript of Whisper like running in the background. That is gonna be the next project. We're gonna probably start, I don't know, Friday, maybe on Monday next week or so, and it's gonna be exciting as well. But for today, I would say this is all. Thank you all for joining in. Thank you all for listening to me ramble on and you know, fight with this stuff. But I think this was fun. So see you next time. You know, thank you for joining in. Let me know if you have any questions. You can always follow me like on YouTube, Twitter, BlueSky, personal website, newsletter, Twitch, LinkedIn, all the places. I'm everywhere. Everywhere. You will see my face everywhere. All right. Thank you all for everything. Have a great night. See you soon.